All right, hello, welcome. Today is the 4th of November, and we have some ops CI/CD demonstrations. The first on the list is Grzegorz. Would you like to take it away?
Yeah, sure. So thank you. Hello, everyone. I'm sorry in advance for background noise. My kids are like playing around, and I need to invest in a better microphone not to catch that much of background noise. But anyway, today I wanted to demo one aspect of cloud native build logs rollout. For those of you who do not know what the cloud native build logs are, long story short, it's a new mechanism that we have been building to avoid writing build logs onto shared local storage. In our case, it's NFS. Yesterday, we managed to successfully unmount all the NFS mount points that we were writing build logs to. So this is kind of done in production, but the rollout took a couple of weeks. So I wanted to highlight how we have done this and what techniques we have used to make it like more predictable and successful. So let me share my screen and show you some graphs. So to put a zoom toolbar somewhere else and go to Grafana. So in Grafana, we have this CI runner service dashboard. There are like a lot of interesting data there. I particularly like this metric. It's the start CI jobs in the last 24 hours. I have 24 hours time frame set here. And in the last 24 hours, we have started GitLab.com processed more than 500,000 jobs. So that's like a lot. And we knew that cloud native build logs are this kind of feature that is going to be under a super heavy load. And we can do some math to try to calculate that. So we have 105, like almost 500,000 of builds processed daily. And there are like, there are no really good metrics regarding the average build duration, but we have histogram, which is not going to tell us much, but there is this duration histogram by worker. And we do have average here, and we can see that the average is like from 49 to like almost 0, depending on the runner's manager. So let's say that the average duration of a build is 20 minutes. So let's go to calculator, and we can now calculate the amount of build seconds a day. Of course, my math might be totally broken, so if you find a mistake, like, let me know. So we have uh, uh, this amount of builds, and then we have 20 minutes uh, multiplied by 60 seconds. So that's the amount of build seconds a day, I think. So now we can basically divide that by 30 seconds, because we know that a build is trying to send a build log to GitLab on average every 30 seconds. A runner is trying to send a build log to GitLab every 30 seconds. So we have around this number of requests to the build log patch endpoint, right? And we can divide this by the amount of seconds in a day, I think, to get the rate. So it's around 235 requests per second. And of course, like, my math might be completely broken, and that's the reason why we have a dashboard for this with a request rate. So as you can see, on average, it might be around 200 operations per second. So we knew that this feature is being used like a lot. And we were about to actually totally rebuild how we store, how we visualize, how we retrieve build logs from Redis and database and object storage. So the question we try to ask ourselves is, how do we know if this actually works? Because as you saw, we process more than 500,000 of build logs a day. And how do we catch a 10, 20, 50 malformed build logs? How do we know if there is a bug somewhere that is actually causing like build logs to be malformed or corrupted in some way? Like we can lose some bytes from inside the build log and never know. And you know, build logs are as important as CI/CD statuses are. So we decided to build a bunch of metrics. We built a few. I don't want to show you all of them, but there is this one idea about sending a CRC32 checksum from a runner to GitLab. And then GitLab, once a build is done, is going to retrieve build logs and calculate checksum and then basically compare it. So there's this merge request. As you can see, we are getting the build pending state and trace checksum sent by a runner from the database. And we are getting data that we have on the Rails side. Then we simply compare that, right? So we've built the code to actually verify whether the feature works. So this code is not really necessary for the feature to work correctly. Without having the checksum verifications, it would behave in a similar way, right? But we decided to build something, write like hundreds of lines of code to just make it easier to verify that the feature works and use metrics during the rollouts. And we created this Prometheus metrics too. And there is a metric, there is a counter that we increment every time we detect a malformed build log. Malformed in the sense that the CRC32 checksums do not match. So let me try to find this metric. So it would be some increase GitLab operations total. That's the name of a metric. Operation is invite vector 5 minutes operation. Sorry. Execute. Okay, so let's visualize this on the last week. So as you can see, we have some amount of invalid build logs detected. The rate is not high. The increase function shows the increase on 5 minutes. So like it's not like a lot. It's 2, 1 on a day. It does not seem to be a very significant number. So you can see how small this number of invalid build logs is compared to the amount of builds that we actually process every day, like 500,000, right? But it was an interesting situation here. We saw a huge increase. So it took some time for us to actually understand what is happening. Then we managed to find this issue that there is a replication lag. It was an incident reported that happened at the midnight on the 1st of November. Yeah, and that is what I wanted to show you. I wanted to show you that you can basically build a code around your feature to validate whether it works correctly or not. You can use Prometheus, Kibana to support the rollout. During the rollout, during the 2 weeks or 3 weeks of the rollout, we had found like a bunch of problems that we could fix quickly because of the metrics and logging we built around this feature. Yeah, and that's what I wanted to show. Are there any questions?
What is a CRC32 checksum? Like, it doesn't ring a bell for me.
So basically, it's a simple algorithm that is going to take the data and calculate a number. It's very similar to, like, it does similar thing as MD5 or SHA.
Okay, gotcha.
But it's more simple, and by
That's more.
some people it has been like considered to be a deprecated algorithm, but it has some really useful useful features that we used here, and MD5 or SHA algorithms would not be really possible to use in this particular case.
Okay, because it's like faster or requires more memory or some other thing, or
So it allows you to take previous CRC number and combine with the new CRC number without actually retrieving data for the first chunk. Like,
gotcha.
I would need to explain it better probably.
Yeah, sure. That's overview is fine. Yeah, cool. Thank you.
Are there other questions? No? Okay, so Fred, you are next.
Thanks. Mine should be a bit shorter. So basically, I was faced with I would say a problem while developing the visualization that we're starting building in the pipeline authoring group, where we want to represent the YAML of a CI config inside a graph. But I kept having to write different configs all the time. And so at some point, I would either copy paste the same configuration, which led to always seeing the same graphs, which isn't good because then we weren't testing a lot of different configuration, or then it would always result in smaller graph because typing a long graph is obviously more time consuming. So for fun this weekend, I decided to go and try and write a script that would generate CI configuration that are valid and that we could use that are randomized. So that way, it would just allow us to test more type of graphs easily. And the idea was for now at least, is that there are jobs, there are stage, and jobs can have needs, and they all have the same script. And eventually that might change. But for now, to show you how that works, I have a small script here. And if I run it, I can pass it different size. For now, there are only 4. So they're small, medium, large, and X large, where X large is really more for performance testing. It creates some interesting graph that I can show you later. But let's say that I run it and I want a medium size graph. Then it generates a dummy GitLab CI configuration here that I can then just copy and paste. And if I go in my file, and I'll just paste a new configuration here, and then I come to change, then we'll have a new graph that has been generated here. There we go. And so this is very useful because then there's a ratio of needs per job depending on the size of the graph. And so the larger the graph, the more needs there are as well. And then we can start seeing interesting, like right here, the combination of a lot of lines crossing, and then that might give us some insight. If we go with like an X large graph, which is going to be a bit slower to load, right? Because that's the goal of this this graph, is seeing, well, how long does it take to render like a graph that could have like potentially a lot of needs per jobs for very bad architecture, let's say, but that could at least show us how we're doing in performance. So if we go, when I click on visualization, we have an interesting result, and to say the least. And you can see the hover is much slower because we are calculating which line we have to render. And so just doing a hover says, well, look at all the jobs that depends on you, right? Or that you are dependent on. And so just rendering that takes a long time. But it's interesting because then having something like this kind of gave me different ideas also of later, right? Like how we could draw the lines differently if there are more than X number of jobs or needs, and that's kind of easy to do. And so we could improve performance. And so this script is useful for that. I would like for this to change a little bit. I would also like this graph to be able to generate upstream and downstream, especially, well, downstream is easier, but generating like different files and having like microservices so that you could technically generate multiple files, and then someone who's not really familiar and just need to test something at GitLab could generate a bunch of files and then just upload them to their repo. Obviously, having demo project is nice too, but sometimes you just want to have a brand new project and generate a couple of files. So that's it. That's all I had to share. Any questions?
Nice.
Sure. I was just wondering if you thought that script might be useful for end-to-end tests for like the quality department.
That's a very good idea. No, I hadn't thought about that, but it could be. I'll sync with people from the quality department. They might be interested in having something like that. That's a good point.
Awesome. Yeah, thanks, Fred. It's great. Thanks, everyone who presented. I don't think there's anything else on the agenda. I'll give everyone 15 minutes of their day back if there's no other questions. Cool. All right, Joel. Thank you so much for presenting. Awesome work, everyone. Take care.